In this app, we will use the historical eruption data of the old festival geyser to demonstrate how to use data to make statistics, to make chart, to make model, and use model to do prediction and make decision. In this data set, we have the eruption and waiting times for 272 eruption events. In order to have a holistic view of the entire data, we used to rely on statistics. And when we actually do the statistics, we might have the impression that most of the eruption time will be around 3.5 to 4 minutes. However, when we look into the chart, we will see that the distribution of the eruption time is not a bell-shaped distribution. It is actually an M-shaped distribution, where most of the data is moving away from its average. Because this summary statistics might be misleading, so whenever it is possible, we should always plot the data. Data visualization helps to discover the structure and trend within the data in an intuitive way. However, chart cannot do numeric prediction and estimation for the purpose of strategic planning. To do that, we will need to do models. Simply speaking, a model is a mathematical representation of a variable, and a distribution function is a model that describes how the value of that variable varies. The easiest model is called data rocks. If we map every single data point to a post function on the variable axis, we will have a PDF and the corresponding CDF. The problem is, the mathematical form of this PDF is very complicated, and because it completely matches the sample data, it may not have the generality to predict the out-sample events. With this checkbox, we can use histogram to build a simple and general model. The slider here controls the number of bins within the histogram. If we set it too low, we will lose information. If we set it too high, we will see this type of glitches, which may be just some local phenomenon that only occur within the sample data and should not be included in our general model. So on the one hand, we would like to capture as much information as possible, and on the other hand, we need to avoid overfitting to the sample and lose generality. So in practice, we will reduce the number of bins to a point that all of the glitches are gone. The mathematical form of histogram is still very complicated, and it is also subject to this type of what we call quantized error. As an alternative, we can use density function. As in histogram, we also need to adjust the bandwidth to control the levels of detail. Well, again, and it is a trade-off between detail and generality, and the sum rule is to preserve the generality without losing too much information. Up to this point, we have demonstrated the modern modeling process in two steps. First, we need to choose among modeling forms, such as data rock, histogram, or density function. And then we need to adjust the model parameter, such as binwidth or bandwidth, for sensibility and generality. In machine learning, we have some technique and tool for choosing model and adjusting parameters, but that is out of the scope of this talk. Now, suppose we want to go with the density function with the 0.6 bandwidth. Here, we can turn on its CDF function for prediction. Here, we can adjust this slider, and the app would estimate the probability that the next eruption time will fall within the range. For example, the probability that next eruption time will fall within 2.1 to 3.3 minutes is 15.2%. In the introductory level, in this video, we have went through the key terminologies in analytics, such as data, statistics, chart, and model. We learned the concept of model form and model complexity, and we have some practice about selecting model, adjusting argument, and using model to do prediction. The last thing that I would like to emphasize is prediction is not the purpose of business analytics. In business analytics, we want to use prediction to make decision, and that will be the content of our next video. Thank you for listening.